So, great. Warm welcome to my talk, Lean Spring Boot Applications for the Cloud. And I'm going to actually show you what Josh Long was not talking about in his presentation. I don't want to fight with him, definitely not. But I want to show you, like, when you go to production, you know, that's his happiest place on earth. Then actually, like, what you need to do to optimize your applications. And I'm on a journey with this talk already for more than a year, and I've been talking on several conferences and did some Java user group talks, and I learned quite a lot in this time, like what you can optimize or how you can optimize your applications. I mean, I had obviously some input before, but also I got some new ideas. And I'm going to, like, explain you those things in this talk. So just a warning. You are all humans, you're all adults, you know when you do benchmarking, don't trust the big vendors because they always have a hello world controller returning a string. Make your benchmarks yourself. So the numbers I'm going to show you, they are just an indicator what you're going to expect when you do some optimizations. So benchmark yourself, right? So that's important. I'm Patrick, and I do quite a lot of things, mostly related to Spring since many years. And I usually develop applications with humans, right? And I do coaching, development, reviews, training, and stuff like this, and also lecture at the University of Applied Sciences. And I'm involved also in the software development community quite a lot, because it's just fun, and we all can learn from each other. So what is the problem? Why do I do this talk? If you move actually to the cloud, you think it should become cheaper, right? It's not, or sometimes it's not. And you start to optimize, and the question is also like in which direction you want to go. And Java is usually my stack, and I do Spring and Spring Boot since ever, I remember. So basically I use Spring since 2007, and that's already quite a long time. And you know, we have now like 20 years of Spring and 10 years of Spring Boot. That's quite a history. So let's dive into the topic. And for me, the thing is, like, when you start trying to optimize, you have to understand like what you need. And the thing is actually, like, when somebody approaches you and asks you, how much CPU do you need for your application? How much RAM do you need? Can you answer that? And then depending on the cloud provider you're using or how your setup is, how much storage do you need? How much network traffic you need? And then actually, like, you start thinking about also your stack. But if I know Spring very well, I'm not going to use any other stack. So, I mean, the stack is for me not really an option because I have like a solution for everything in the Spring ecosystem. So I have to find out like how I deal with resources in general. So that means certain cloud providers say, if you use this amount of RAM, then you have to use this amount of CPU. And if you go higher with the RAM, that might mean that you need more CPU, or at least you have to pay for it, right? That could be an issue. So you might optimize there. And also you might optimize when you have a new deployment going on for example, image size, and obviously also the network bandwidth. And that might even affect your production application. So what we are going to look at also in our application is maybe like elastic scaling. So you think of startup and shutdowns. For you, it's also important like how many users can be at the same time on the application. So throughput and latency might be another topic you have to consider, right? So we are going to talk about many things. First, I define with you the baseline for my optimization benchmarks. And then afterwards, we are going to have a look at different Java optimizations, Spring Boot optimizations, application optimizations, other runtimes, and many more things. And in the end, I'm going to show you how you really like let your application start up like in half of the time using about 30% less RAM. I know, it's quite a statement. So the Spring Pack Clinic, you probably know, that's like my application for the benchmark. You can download it obviously from GitHub, and you can do the benchmarks yourself. And also my examples are published on my GitHub account. So you'll find them, and you could see like what kind of tweaks I did. And I'm going to show you also like how things were done. So the Spring Pack Clinic is a simple CRUD application, so there is not much actually. There is a database and a server-generated front end. The Spring Pet Cleaning community is not what we are going to look at, but I just want to tell you here, if you want to look out for a new technique or technology, there are many pet clinic clones out there which belong to the pet clinic community, and you can get inspired how you set up your project with a particular technology. So keep that in mind. We're not going to use that. We are going to use the official pet clinic, where I use like Spring Boot, where I use a cache like Caffeine. The server-side rendering is Thymeleaf. Spring Data JPA is used. H2 in this example for the benchmarks because it's just easy to set up. And I'm using Spring MVC underneath. So that's actually like the application which we benchmark. So it's not really rocket science. It's just a regular application with some logic in there, some little logic, some rendering, some data access and stuff like that. So if we are going to now optimize the thing, that you need to know, like when you're using Spring Boot, by default, if you use the Spring Boot Maven plugin or the Gradle plugin, when you are going to create containers with it, then actually we use the build packs. And build packs are a great tool for that. So I don't write my own Docker file, and you will in a minute see why. We use like the regular JDK 17 as a benchmark, so I can show you also 21 afterwards. And I'm having here also like the Spring Boot 3.2 as a current version of it. And on the other side, you see we are going to look at build time, startup time, resources in general, that means RAM, container image size, and throughput in the application. So build packs are awesome. Who of you is going to or is using build packs for the application? Awesome. So why build packs? Why not writing your Docker file? It's actually that build packs prevent that you're going to like think too much how to create the perfect Docker container. And with Paketo, the tool underneath, you create the optimal and probably the best container image you can have. Because it's made that you can use it with different technologies, as you see on the picture, and Java is just like one part of it. And what I love here, especially is if you do that with your Spring Boot application, you see something above the banner, above the Pet Clinic banner. You see there are things like, for example, some parameters regarding memory tuning, like the XMX parameters and others, which are necessary for containers. And these kind of things were just like calculated by something which is called the Java Memory Calculator, which is part of the build pack. So it guesses, because of the amount of classes you're using, the parameters, and just puts them there when you start the application. It also knows, and that's like the first line, how many CPUs you're providing to the application. And that would be also like integrated into the calculation. So that means like if you're going to change in your Kubernetes environment, like the amount of CPUs your application has, the calculation might be different, or should be actually different, right? So the first part of it is obviously very important. And another thing which is actually great is your application doesn't run with a root user. It uses a non-privileged user, which is also more safe. And that's actually like very important. So it's a great thing, and I don't have to think of how to create the perfect container or like the perfect secure container. So what you just learned is build packs are 1,000 times better than your regular Docker file, and you should actually go with that technology. And behind the scenes, they are maintained by the build packs community. And for example, if you just use the regular build packs, which has Ubuntu underneath, if there is a vulnerability, they will be usually usually fixed within like 2 to 3 days. So you get the updates almost immediately. So it's upstream from the canonical Ubuntu project and then directly into your build pack, basically. So you just need to rebuild your containers. When I was preparing the talk, I was thinking like, yeah, what is else there so I can understand where I have the pain? And Maciej, a colleague from Berlin, has done a project which is called this Spring Boot Startup Report. And this just like reads the information out of your actuator from Spring Boot, like some metrics, and creates an interactive HTML page. And also you will see some nice charts. And this is a thing where you could get an idea how, or now actually where, you lose the most time in the startup of your Spring Boot application. It looks like this, and you have a drill down where you can actually see like how much time you're losing. And then if you dive a step deeper, you will actually see a flame chart, right? And since the applications, the Spring Pet Clinic, uses Hibernate underneath, I was actually surprised how much the configuration within Hibernate takes time during the startup of the application. So, I mean, I was not so aware of that, but actually, like, there is lots of magic going on behind the scenes, and you could see that in this flame chart. And you really can dive into these different parts. And these are just the metrics which are automatically provided by the actuator. So have a look at it, so you get a better understanding like what kind of infrastructure you're using and where you lose time without even using a profiler or some other tools. Okay, but now on the side, let's have a look at the benchmarks. For me, the thing is I look at like how I build my application, how long it will take, how big is the output. Then actually we have a look at the startup time and the memory. We look at throughput and latency. So I'm using here WRK2 to actually generate some load with these parameters. And I also do some warm-up, and I also do some measurement phase to make sure that the Java optimization actually kicks in and that actually like things is warm so we have proper measurements. And I'm using a Docker container with 4 CPUs. I mean, maybe like depending on the application, I don't need so much, but 4 CPUs is usually the sweet spot of like a Java application starting up in general. Because if you use less, then it's kind of linear with the time you lose, basically. If you put more, you don't win a lot. So the part below, like towards like, I would say like 0.5 CPUs or so is more like linear, and above it's more exponential. So you need way more effort there. And the Pet Clinic doesn't need a lot of information, or yeah, doesn't need more RAM. So let's like have a look how a regular Spring Pet Clinic looks like. I'm just going to use here SDK-man. So as you can see here, I'm just like using the regular version of JDK 17. The JVM memory calculator is in there too. I just do like Spring Boot build image, and then I run it. Then actually, you see on my specific machine I'm using, and I'm not using my notebook. That's very important. I'm using a water-cooled desktop machine at home where I can make sure that all these benchmarks are comparable, because thermal throttling will kick in on your notebooks, and that's just like a mess with the numbers. So don't do that. Make sure that you have like consistent temperature on the CPU, and then you get comparable numbers. So you see here like the build, the regular build actually takes like 60 seconds with an image size of 300, almost 50 megabytes. We have a startup of 4.8 seconds. We use initially RAM, just like when we start without doing the load test, we have like around 300 megabytes of RAM used. Then we try to hit actually the application with 2,000 requests a second. And then you see actually like after this 1 minute test, the RAM went up. And you also see kind of the distribution of the latency of this application. So you could see like 99.99% of the times we have an answer within like 164 milliseconds. So that's just like the regular baseline. And we are going to compare this all the time against this one. Now with JDK 21, things got way better to a certain extent, but you see numbers are slightly different regarding the image size, because it's a little bit bigger. It's like startup time is like around the same. I'm saying around the same because like my benchmarks are not perfect, and you can take like 100 benchmark runs and the numbers look different, obviously. So I usually try to do multiple of those and then averages all the results. So actually here I would say the numbers are roughly the same. You see also like the memory usage, the throughput, same direction. But what we see is actually like the latency gets better towards the end of the tail, right? So that's an advantage. And what I have learned, even during benchmarking other things, actually like the micro version changes of the JDK make a huge performance impact all the time. So Java 21, when it was released, was not so good like as the 21.01 release. They obviously do some performance improvements, I guess, after their major release. Then you can come up with some ideas, and now I'm just using a few parameters like no verify. So you're not going to verify the classes, and you just can easily add that to your Docker command to provide this Java options environment variable. And obviously that's not a safe thing. You should not do that in production. But I mean, if you remove the checks, the numbers should get better. And as you can see here, they get better because the startup is faster, right? And the other numbers are roughly the same. You could do something like also with the JIT. And you could say, for example, yeah, I don't want to have a JIT which optimizes too much. So I just like say, I'm using the C1 instead of the C2 JIT compiler. And it really depends like on your operating system and how many cores you use. The default would be typically the C2, but if you restrict that with this XX tier stop at level 1, you say, I'm using just like the C1 compiler. And here you see, this is actually made for fast startup, but the numbers are not wrong. It's really like around 20 seconds when we have the response like with the things here. So it takes way, way longer if you put load on the application. So this is definitely not an option, but in case you want to do serverless, like functions, this would be an option because you throw the function away after the first usage. So you don't need to have something like a C2 there and yeah, add this additional infrastructure in the startup. So that could be an idea. You could think of also like using different garbage collectors. This is just an example, and like this low latency garbage collector doesn't make sense in kind of Spring applications. You see that also when you look at the numbers with RAM, for example, but also with the throughput numbers. All right. If you want to optimize more on the JVM, because I don't do that, I found this thing, it's called JVM or VM Options Explorer. It's actually an awesome tool which actually lists all the thousands of different parameters you can use on any JVM distribution you know. You should have a look at that because that's really cool, and you would see like no verify works on some distributions but not on others. So sometimes like they are slightly different. Just have a look at this. This is for additional information. Now let's have a look at some optimization from a Spring perspective or from a Spring Boot perspective. You could say, let's make all the Spring Beans lazy. That actually makes my application start fast, right? If they are lazy, the first request which hits the application is actually slow because of that. Right. And that's something you can do with the two parameters. And I'm adding actually two, the one for lazy initialization, which is for the regular Spring Beans, but then I make also Hibernate or Spring Data JPA initializing lazy as well. You should not forget that part because, yeah, that makes a huge difference, as we just also learned with the startup report. So you can do that, and that means like your first requests actually get slow because of that on the application, but since the benchmark contains a warm-up phase, well, everything is already initialized, so the application behaves roughly the same as a regular thing. So lazy Spring Beans are good for starting fast, but the first hit will be expensive. Obviously, you can imagine lazy Spring Beans are great, but the thing is actually you want to have like feedback during development, so you make sure that things are covered by tests, and you make sure if something breaks, why it breaks. Another thing I think you can do if you want to, and if you're brave, is a thing called removing the Spring Boot actuators. Because we know actuators are great, health checks are great, observability features are great, but if you don't need them, remove them. And I'm showing you why, because we need less Spring Beans. And as you can see, no actuator means like 274 Spring Beans compared to 449 Spring Beans. So just to create this additional, like roughly around 180 Spring Beans, it takes some time during the startup. So you see the startup is actually good, and then also you see in the throughput that the numbers are looking better because there is no overhead because of these metrics and observability. So that's actually like the huge advantage. And I'm just running the application as before, but just like having not the actuator starter in my Spring Boot app. Right. Another idea you can come up with would be like having a specialized path to your application YAML or application property file. Because Spring Boot is going to search in different locations and merging the property and YAML files together in a way. And if you just know like where the file is, you point to that one, and then an application starts faster. That's an easy thing. So that means like in our case, we just provide the environment variable for Spring config location. It looks like a property. It is also a property, but I set it as an environment variable, and it gets converted anyway from Spring Boot. So I say where the file is, and then this check actually is removed, and we start faster. You see it's like 30 milliseconds or something like this, right? The rest should stay roughly the same because in the application things don't change much, right? So there is not much additional infrastructure more there or overhead and something like this. But you'll see also here, I mean, we have some variations in the numbers. That's just probably a measuring error. I don't lie to you, I show you the real numbers actually. It's not a vendor benchmark what I do here, it's a real one. Okay. Another thing, you probably know that, for example, if you're using JMX, there is also additional infrastructure. There might be other things there too. And the great thing is actually like that Spring Boot disables in production JMX by default. And even the build packs actually like disable everything from JMX. So you don't need to do anything. But if you want to use it, you can enable it, and that's why I put the properties there. But by default, since Spring Boot 2.2, it's already gone. Spring Boot is production ready, right? So they have a mindset that like everything is for production and not made for development. So that's why I love Spring Boot and build packs, because it's already in there and they don't have to care. Great. Another thing, now we start to optimize our application. And obviously, I mean, there are many ways to optimize your application. But without looking actually at your business code and how you did things, you can clean up the dependency you don't need from your starters. Because starters are made to start, not to finish. So you have to clean up later. That's like with writing documentation, right? You always do it later. Don't forget about it. So I came across a very nice Maven plugin, which is called depclean. And the depclean Maven plugin allows me to find out which dependencies are really used, and it provides an awesome report at the end, so I can have a gut feeling what kind of dependencies are used or not used. So I highly encourage you to use it, because you can create also a flattened POM. You can create one where all the dependencies are in there with all the transitive ones, but also the most important part is actually creating the report here. And I had to add some 3 dots in there that you see all the areas, because a Spring Boot app has quite a lot of dependencies. From the dependency report, you get an idea which dependencies are used and which ones not. Bear in mind, we have a problem here. Spring uses reflection and other functionalities, and then it's actually quite difficult for the tool to find out which are the imports and so on, because there are strings everywhere. So you might need your gut as well to come across this idea that certain things from Hibernate might be not in there, but the report says something like potentially unused, right? So you have to use your brain. So there are just like some things to tell you, things like component scanning, things like entity scanning, things like the auto configuration import file, or if you're still using the Spring context indexer on older version of Spring, this file also just contains some classes in there. If you have the WebXML, this stuff actually does not work with this dependency clean plugin. But you know your application, and therefore you can judge if you are going to remove or not your dependency. And that tool now in my Spring Pack Clinic removed for me like about 9 megabytes of dependency. The build took longer because creating a report takes about 7 to 8 seconds, as you can see. But actually the application is better, and also like you see that with the usage of RAM, things got way better over it. So you should actually like remove the things you don't need. And it's an easy thing, and we didn't optimize too much within your logic and in your application, right? That's an easy thing to do. Now, there are new things actually in Spring Boot since last year, oh, not the year before actually, and they introduced ahead of time processing, and I'm talking here not about Graal VM native images, just about the generation of the additional code. So the thing is actually like that the ahead of time processing creates for you code which generates Spring Beans instead of doing component scanning or entity scanning, for example. And they'll use internally the low-level API, and that means you have code instead of doing class path scanning. And that code will be used during the startup, and your startup should be faster because of that. And that's just like a small part you add to the Spring Boot Maven plugin, and it will generate the code for you. And it's interesting that conditions, for example, are also evaluated. So it does quite a lot of magic, and this AOT plugin within the Spring Boot Maven or Gradle plugin is actually the replacement for the Spring indexer, for the Spring context indexer, because it's not supported in the current version of 3.2 of Spring Boot anymore. So what do? I mean, you run this ahead of time processing, and what you will realize, you have a bigger image size because there is more code. I guess here the 1 megabyte is not accurate. I think it would be like a few hundred maybe kilobytes or so, but the startup is already faster, as you can see. And also the execution is slightly better. Okay, so there is another idea. Probably you've heard of J-Link. And why don't we always just like create in our containers a customized JVM? Because that's the reason why the module system is in Java. So we can actually like take out the parts which we don't need. So therefore, instead of doing it like with a script here, there's a nice thing to do it for you because it's super easy. It's just like an environment variable you pass to the Spring Boot Maven plugin and basically to the build packs, and it does it for you. It removes the unnecessary parts of your JRE and makes your container image way smaller. So that's quite nice actually, and it's basically for free because it's just an additional, with formatting like 5 lines or so, right? So you have like less JRE in there, and your application should be slightly better, well, and faster because there is like less chunk to carry with on. Okay, so this J-Link optimization with one flag does kind of a few things. But since the Spring team doesn't provide the module info in the jar files, you would have to do additional steps actually to find out like which modules from the JDK is needed. And since I know it better for my application, I do it like this. So I name the modules I'm going to use, and I even say things like I do a little bit more compressing. I say I don't need header files. I need no man pages in there, no debug stuff needed. So I can remove this, and now you see there is quite a lot of reduction actually in the image, about 80 megabytes. That's quite a lot, right? So that's definitely a benefit to shrink your containers. And then you also see here, we have quite better numbers almost overall. Right. Great. So you see, just like one environment variable there, and it's done. So you should do it. It's almost for free, right? Great. So the next step would be having a look at different JVM distributions. Because like in the past, I always heard, yeah, OpenJ9 is way better. And if you go on their website, they just like claim that. But the problem is, it was for Java 8. And that's a long time ago. Well, you can still stay on Java 8 for Java applications till 2030. It's supported, but nobody wants to work on Java 8, right? So therefore, these are not the real numbers we think of, and I can show you this actually also in my benchmarks. So I need to add additional build packs here, especially here the Eclipse OpenJ9 build pack, to make sure actually like this one is used and we get OpenJ9 into the container. And then you see, well, we have a smaller image size. Startup is getting way worse with the defaults. Wow. Throughput is also is slightly better, but well, that's basically nothing. And then you have like the things like with the throughput in the end. So no, not really better, but you can go and just like optimize the thing here. You can use some parameters. You will find them in the internet, adding some Java tool options which are meant for containers. And then you see like the startup even got worse, and the throughput might got slightly better actually. I mean, you can do some tuning here if you want to. But I found out that's not a solution for me. Another thing could be just like running the things with the Graal VM, because it has a better JIT than actually like the hotspot OpenJDK thingy. So you can do that in the similar fashion. You just add the Graal VM build pack. And actually, you have to add also the regular Java build pack, because it inherits like other steps which are needed to be done as well. The Graal VM one doesn't do that. It's using here the community edition of Graal VM, because just like I think a few weeks ago, they released the Oracle version as well. So it's pretty new actually, and I haven't done some checks with these ones yet. So Graal VM is huge. But you can see actually that the JIT is way better doing optimization, and we get way better throughput. So just by switching the JVM implementation, basically, I'm not talking here about native images still, well, it's getting better, right? And then actually, like, that's my favorite part, is actually using other builders for the build packs. And there is a company called Bellsoft. And you have, usually when you use IntelliJ, or if you're using Spring, you have Liberica automatically used because it's the default for both, right? And if we use their builder, we can have, instead of Ubuntu, an Alpine, which is called Alpaquita, and they have like two versions, one implemented with Muscle, and on the other side with glibc. So I added both, the M for Muscle, the G for glibc, and you can see you can shrink actually like the container image quite a lot. And you get also better numbers in case of the glibc, which is expected. The Muscle is more newer, more secure. It's not like a mess like the glibc. And you get like also with throughput and latency good numbers. Right. So I think this is just a no-brainer, shrinking things down. And even what surprises me, that the Muscle implementation here uses like less memory, right? So that's really nice, shrinking actually the usage of the memory of your application. Obviously, we don't need to forget about the Graal native images. And there the thing is, as you know, it takes about 6 to 8 times longer to build. But actually your applications are blazing fast, right? And I mean, with the startup. But if you put the same amount of load to the application, you see it's not so nice. And the problem here is I'm using the community edition. It's not so sophisticated like the Oracle Graal VM free edition you can use in the cloud. At the point when I did the measurements, there was no build pack. And I just saw, like, I think a week ago or so, they released a build pack, so I'm going to play with that soon again. Right. There is another technology out there which is called Crack. And it's about checkpoint recovery, and it makes, in Linux, basically a snapshot of your application. And then actually when you start up, you can use the snapshot and just like start your application within milliseconds. And I tried that, but I had to script it myself, and I'm waiting still for the build pack so that every one of us could leverage this, because it would be so nice to do that. Right. So I don't have proper benchmarks, but the thing is really like, as you can see in the step, you build your application, you create the checkpoint, you put the data, the binaries into a folder, and then actually you just use the last line, and you don't see Java -char there anymore. You just restore from that folder, and the application starts. That's basically the idea. It only works on Linux, so macOS, Windows with WSL is not working. And in the last Spring release, so in the Spring 6.1, they just added these capabilities, because it's very important that your Spring application knows about the state of itself. And for example, Spring needs to close sockets which are open before the snapshot is done, and they are going to restore the sockets after the snapshot is done. So there's quite a lot of like magic going on, but it's actually a very nice feature, and I just wait for the moment to use build packs here, because I've been talking to people from Belsoft and also from Azul, which provides you this technology to get a build pack. So I hope we get something there, or we just do it like open source. Another feature, obviously it's everywhere because of Java 21, it's virtual threads. And I need to use that too. So I'm using here Java 21 again because of virtual threads. I use that single property to enable it. And you know, the embedded Tomcat of your Spring Boot application will automatically use virtual threads. And look at the numbers. It's getting better. I mean, you slightly need more initial RAM at the beginning to do that, but then the optimization kicks in and it's actually way faster. And I think it's really worth it just to enable on every Spring Boot application this thing with the virtual threads, because you get way more requests through your application and you have way better latency. Right, so I'm getting here. So my summary of the talk and like showing you like combined optimization steps. We have done now quite a lot of things. So I showed you here lots of optimizations. We went through all of those already. You might still remember, right? And now the question is like, yeah, what did we learn from this? And the conclusion is definitely for me, if I talk about CPU usage, I learned that 2 CPUs are good. 4 CPUs are way better because it's twice as fast, for sure. If you have less, it doesn't matter, but your use case need also to be aware of that it might take longer to start your application. I mean, it's obvious if you have a Spring Boot application and you just provide like 0.2 CPUs to it, the startup might take like, I don't know, 40, 50, 60 seconds. Well, that's the thing. If you have more and you need more CPU afterwards, it's worth it to like apply more CPU. Yeah. And the 4 CPUs are like the sweet spot, if you afford that, right? Also, like, throughput is a thing you have to consider in your own application, right? You have to check like what makes sense. You need to do proper load testing. Don't take my numbers for granted. Your use case might look different. And another thing is make sure that you're going to use like newer versions of the JDK. Have a look at different distributions, right? Play around with this, measure the things, and even like paid versions of a JDK distribution, they may have a use case. Because better JIT, better features, whatever, it sometimes really makes sense to go with them if needed. So yeah, great. I've been also looking at other things. So for example, I came across the idea that I want to obfuscate everything to shrink even the classes. It's super difficult to do that. There are other things, for example, like app CDS, where you basically store all the classes into one file and you start your application from that file containing all those classes. You could also do something crazy like importing all auto configurations manually instead of using like the discovery mechanism from Spring Boot. You could also use, for example, functional bean definitions. That's another way. And then actually like do some more tuning. And also I'm looking forward to new projects in the Java ecosystem which should like make your applications faster, like this project Leiden, where they started a repository in, I think it was September last year. So Oracle just like did for a year like some tests on it, and now actually like the repository is there and you will see the things going on there. Now, like summarizing things, how can you apply some optimizations? Like, for example, dependency cleanup, using a different build pack, using JLink, using the Java memory calculator, using AOT, using lazy Spring Beans, having a fixed place for the YAML or property file, and using virtual threads. Obviously, you cannot do like all of those together, because virtual threads is Java 21 only. So that's why I'm going to provide you 2 solutions at the end. If you're still on Java 17, you see now the combined things together, where you can see that we are going to basically like reduce the amount of dependencies and also like shrink the container image quite drastically. Startup time is like way more than half of the initial one. RAM usage is also way better, and we get way better throughput and the latency, right? So that would be an idea how you could apply all these things I was talking about, and now you have like the Java 17 version. In case you are going like with Java 21, make sure that you have like virtual threads enabled as well, and you do the same, and you see we go even below the 2 seconds for the startup, which is actually quite nice. And then also, I would say, like the response times are also still like very, very good compared to like our initial state, right? So let's conclude the thing. Did I miss something? Do you have some other ideas what I can do? Let me know. Because I would love to learn also from you some more things so I can spread the word. Yes. Questions? Well, you can come down and let's have a chat.